Innovation is the only sustainable form of differentiation. Hi, welcome to another series of innovation news updates from NTT ComDD. My name is Hui-Yung Seong. In this demo, we will integrate an IoT device with Azure Digital Twins through their API to gather room temperature and humidity data. From there, we can create instances to identify which room is overheated. So what are Azure Digital Twins? Azure Digital Twins is an Internet of Things IoT platform that enables you to create a digital representation of real-world things, places, business processes, and people. It enables the creation of knowledge graphs based on digital models of entire environments, combining data from all your IoT devices, business applications, and any other data source to model, monitor, and manage real-world environments. This environment could be buildings, factories, farms, energy networks, railways, stadiums, and more, even the entire cities. These digital models can be used to gain insights that drive better products, optimize operations, reduce costs, and break through customer experience. Azure Digital Twins can be used to build customized connected solutions that model any environment and bring digital twins to life in a scalable and secure manner. Connect assets such as IoT devices and existing business systems using a robust event system to build dynamic business logic and data processing. Query the live execution environment to extract real-time insights from your twin graph. Build connected 3D visualizations of your environment that display business logic and twin data in context. Query history, environmental data, and integrate with other Azure data analytics and AI services to better track the past and predict the future. Consider the following example where we define an environment that represents our NTT ComDD office building using the Azure Digital Twins graph shown here. In this example, our building is composed of digital twins that represent the floors of the building and the rooms on each floor. The lines on the graph that connect a floor to a room are called relationships. Relationships help to define how our digital twins are related to one another. In this case, the relationship tells us that a floor contains rooms. The graph shows that our building has floors, and 34F floor contains 2 rooms, but our environment could be expanded to include more floors and more rooms on each floor. Or we could create more levels of detail, such as adding digital twins that represent digital entities within the rooms. Models for Azure Digital Twins are defined using the Digital Twins Definition Language DTDL, which is based on JSON-LD and is programming language independent. Within the model definition, the top-level code item is an interface which encapsulates the entire model. Azure Digital Twins uses DTDL version 2. The DTDL model interface may contain 0, 1, or many of each of the following fields. Properties. Properties are data fields that represent the state of an entity. Properties have backing storage and can be read at any time. Telemetry. Telemetry fields represent measurements or events and are often used to describe device sensor readings. Unlike properties, telemetry is not stored on a digital twin. It's a series of time-bound data events that need to be handled as they occur. Component. Component allows you to build your model interface as an assembly of other interfaces if you want. Use a component to describe something that is an integral part of your solution, but does not need a separate identity and does not need to be created, deleted, or rearranged in the twin graph independently. Relationships. Relationships let you represent how a digital twin can be involved with other digital twins. Relationships can represent different semantic meanings such as contains floors, contains rooms, etc. Relationships allow the solution to provide a graph of interrelated entities. In our setup, we have a Raspberry Pi computer connecting to the temperature and humidity sensor in a meeting room. When we need to interact with our Azure Digital Twin instance, we mainly use Azure Digital Twins APIs and SDK for language such as C#, Java, Python, JavaScript, and Go. In this scenario, we have developed a client application using Python language and run it in a Raspberry Pi. Microsoft has developed a client application called Azure Digital Twins Explorer, which allows us to use its graphical interface to interact with our Azure Digital Twins instance to perform things like uploading and exploring models, uploading and editing graphs of twins, running queries against the twin graphs and visualizing the twins graphs, etc. Now let's start setting up Azure Digital Twins for our demo scenario. The first step in working with Azure Digital Twins is to create an Azure Digital Twins instance that will hold our graph data. Let's navigate to Azure Digital Twins portal. Once in the portal, search for Azure Digital Twins in the search box and then choose the Azure Digital Twins service from the results. Click on Create Azure Digital Twins. Fill in the fields on the Basics tab of Setup, including the subscription and resource group. In this case, I will choose the NTTCDD Digital Twins and a resource name for our new instance and the region. Check the Assign Azure Digital Twins Data Owner role box to give yourself permission to manage data in this instance. Select Review Plus. Create to finish creating our instance. You will see a summary page showing the details that we have entered. Confirm and create an instance by selecting Create. This will take you to an overview page tracking the deployment status of the instance. Wait for the page to say that the deployment is complete. After deployment completes, use the Go to Resource button to navigate to the instance overview page in the portal. Next, select the Open Azure Digital Twins Explorer preview button. This will open Azure Digital Twins Explorer in a new tab. Azure Digital Twins Explorer will automatically connect to our instance. Next, we will use Azure Digital Twins Explorer to set up the models and twin graphs. Now let's take a look at the model files that have been developed. Our building scenario contains a building, floors, and rooms. We will need one model definition describing what a building is, one model definition describing what a floor is, and one model definition describing what a room is. Later, we can create digital twins that are instances of these models representing specific buildings, floors, and rooms. Models for Azure Digital Twins are written in DTDL, a data object language similar to JSON-LD. Each model describes a single type of entity in terms of its properties, telemetry, relationships, and components. To start uploading the models, we will switch back to Azure Digital Twins Explorer. In the Models panel, select the Upload a Model icon that shows an arrow pointing upwards. In the open window that appears, navigate to the folder containing the model files on our machine. Select Building JSON, Floor JSON, and Room JSON, and then select Open to upload them all at once. Azure Digital Twins Explorer will upload these model files to our Azure Digital Twins instance. They should show up in the Models panel and display their friendly names and full model IDs. You can select View Model from any of the models option to see the DTDL code that defines each model type. Now there's some model definitions that have been uploaded to our Azure Digital Twins instance. We can use these definitions to create digital twins for the elements in our environments. Every digital twin in our solution represents an entity from the physical environment. We can create many twins based on the same model type. For example, multiple room twins, they all use the same room model. In our scenario, we will need a digital twin for the building and a digital twin for each floor and room in the building. The twins will be connected with relationships into a twin graph that represents the full building environments. We will upload a pre-created graph containing a building twin, 2 floor twins, and 2 room twins. In the twin graph, select the import graph icon that shows an arrow pointing into a cloud. In the open window, navigate to the building scenario Excel file that we have written. This file contains twin and relationship data for our scenario. Select Open. After a few seconds, Digital Twin Explorer opens an import view that shows a preview of the graph to be loaded. To finish importing the graph, select the Save icon in the upper right corner of the Graph Preview panel. Azure Digital Twins Explorer will use the uploaded file to create the requested twins and relationships between them. Make sure you see the following dialog box indicating that the import was successful before moving on. Select Close. The graph has now been uploaded to Azure Digital Twins Explorer, and the twin graph panel will reload. It will appear empty. To see the graph, select the Run Query button in the Query Explorer panel near the top of the Azure Digital Twins Explorer window. This action runs the default query to select and display all digital twins. Azure Digital Twins Explorer retrieves all twins and relationships from the service. It draws the graph defined by them in the Twin Graph panel, and now we can see the uploaded graph of our scenario. The circles represent digital twins and the lines represent relationships. The Grand Park building twin contains the first floor and 34th floor twins, and 34th floor twin contains Kyoto and Sapporo rooms. You can select a twin to see a list of their properties and their values in the Twin Properties panel. Here are the properties of Sapporo room. Notice that Sapporo room has a temperature of 26. In the Azure Digital Twins, we can create the twin graph to answer questions about our environment using the SQL-style Azure Digital Twins query language. One way to query the twins in our graph is by their properties. Querying based on properties can help answer questions about our environments. In a fully connected, data-driven scenario, the properties of the twins will change frequently in response to IoT data from the sensors in the environment or other connected data sources. Now let's start by running a query to see how many twins in our environment have a temperature above 25. Run the following query in the Query Explorer panel. Select from Digital Twins T, where T temperature is more than 25. If we recall from viewing the twin properties earlier, Sapporo room has a temperature reading of 26, and Kyoto room has a temperature reading of 20. For this reason, only Sapporo room shows up in the result here. Now, let's try to simulate that with our own client app and its associated sensors. But before that, in order to allow our client app to interact with our Azure Digital Twins instance, we need to configure the app registration with permissions to access Azure Digital Twins. There are two types of permissions required. First, a role assignment for this app registration within the Azure Digital Twins instance. This role will determine what permissions the app registration holds in this instance, so we should select the role that matches the appropriate level of permission for our scenario. In the Azure portal, open the page of our Azure Digital Twin instance, select Access Control, IAM, and then select Add, then Add Role Assignment. Open the Add Role Assignment page, assign the appropriate role. Once the role has been selected, click on Members and then select Members. So in this case, we will select our app, NTTCDDADT, then click Select and click Review plus Assign. You can view the role assignment that has been set up under IAM Role Assignment. The app registration should show up on the list along with the role assigned to it. The second type of permission is the API permission. We will grant our app baseline read-write permissions to the Azure Digital Twins API. Go to the app registration, click on this app NTTCDADT, and then select API permissions from the menu. On the following permissions page, select Add a Permission. In the Request API Permission page that follows, switch to the APIs my organization uses tab and search for Azure Digital Twins. Select Azure Digital Twins from the search results to continue with assigning permissions for the Azure Digital Twins API. Next, we will select which permission to grant for this API. Expand the read permissions and check the box that says Read Write to grant this app registration reader and writer permission, and select App Permission when finished. On the API permission page, verify that there's now an entry for Azure Digital Twins reflecting read, write permissions, and lastly click on Grant Admin Consent for NT-TAP Innovation Center. Okay, let's switch to the console of the Raspberry Pi, and we will run our client app to start collecting the sensor data, and I will turn on the camera to show you what our Raspberry Pi computer looks like with its connected sensor. We have started to run our client app, so you can see that it has started to collect the temperature and humidity data, and this data will be sent to Azure Digital Twins continuously. Let's switch to Explorer and let's do a default query. We are sending the sensor data to this Sapporo room. So let's click on this Sapporo room. We can see that this is the temperature data that we are collecting right now. Let me try to increase the temperature for the sensor. Look at the camera. You can see that the temperature is increasing gradually with the heat generated. And again, if we refresh the data on Sapporo room, we can see that the latest temperature data has been sent to the Twins graph as well. This concludes our demo of Azure Digital Twin. Thank you, and we shall see you on our next episode of NTT ComDD Innovation News Update.